Water. We use it countless times per day. It flows endlessly out from the pipes in our walls to fulfill our every need, and we don't give it a second thought, particularly since we live in rainy Vancouver, where fresh water seems overly abundant. It has become something that we use unconsciously. So let's take a closer look at our precious resource and examine ways to create conscious water use in building design that will help improve our lives. Let's begin at the source. Freshwater accounts for only 2.5% of the worldwide water. However, almost 70% of that water is locked away in glaciers. That means that we only actually have access to a third of our freshwater, or about 1% of the world's total water. As Canadians, we are fortunate enough to have 20% of the world's freshwater sources located in our country. However, that comes with a price. We are also one of the world's top water consumers per capita. As a country that claims to be a leader in green and sustainable design, this is unacceptable. We need to become more accountable as a nation for our consumption. We are already familiar with high-efficiency fixtures and Energy Star appliances, and those are a good start to fixing the problem. However, as designers, we have the possibility to really make a change in regards to water consumption by incorporating blue, green, gray, and black water initiatives into building design to help create a more water-friendly environment. Blue water refers to all the fresh water in the hydrological cycle that is readily available to us, like lake water, river water, and aquifer underground water. These are the main sources for our municipal water supply. However, with climate change and increasing consumption, the hydrological cycle is changing. Water is being kept for longer periods of time in its various stages, and this causes things like droughts, flooding, and creates an unexpected cycle of water around the world. Our blue water sources are extremely precious and should be touched as little as possible because they are increasingly at risk. The following sustainable initiatives can be implemented to help maintain this natural cycle of water. Precipitation is one of the stages in the hydrological cycle where it is incredibly easy to get access to fresh water. By harvesting or catching this water in a relatively simple system, buildings are able to mitigate the amount of water they require immediately from the municipal systems as well as store water for future use. The process begins as rain falls on the roof and is directed to the gutter and then downspout pipes. Before entering the storage cistern, the rainwater is filtered to remove any basic impurities. The water is then passed to the cistern for immediate or future non-potable use. In most municipalities, straight rainwater is not considered potable due to the fact that it flows over contaminated roof materials. In instances where the filtration system is not adequate, uses of harvested water are kept to toilet flushing, washing machine usage, and landscape irrigation. Regardless, using harvested water in place of blue water for daily water-related processes within a building lessens the stresses on our aging municipal infrastructures and finite blue water sources. Green water refers to the water that falls as precipitation and remains in the soil or vegetation temporarily between phases in its hydrological cycle. Plants are natural filters that clean and manage the water in this cycle by allowing it to penetrate to the underground water table as well as returning it to the atmosphere through evapotranspiration. Exploiting and incorporating these ideas into building design allows us to access more of the fresh water that falls in the form of rain and to use it sustainably. Like the name suggests, green roofs contain greenery and living plants. Along with the plants come all the various water management benefits that they possess. As precipitation falls on a green roof, the combination of plants, bioretentive soils, and coarse gravels filter the water. The naturally cleaned water can be harvested for use throughout the building for non-potable uses such as toilet flushing and other landscape irrigation. The water that the plants hold onto eventually gets released back into the atmosphere and returns to the hydrological cycle. Bioretention swales, or bioswales, take advantage of the fact that liquids flow downhill and harness contaminated water from streets and sidewalks. As the polluted water drains down through the various layers of plants, soils, and gravels, it is filtered and cleaned. The majority of the cleaned water is then returned back to the underground water table by infiltration, though some water can be caught and added to the municipal water system through pipes. Permeable surfaces are another way of allowing surface water to infiltrate the ground. Used in place of solid concrete or pavement, It provides the same solid feeling surface but contains gaps through which the surface water can flow. The water is filtered through gravels and soils before replenishing the water table and getting added to the hydrological cycle. All of these green initiatives have the same things in common. They all improve the quality of the water surrounding and penetrating the building. The fantastic natural filtering ability of the plants create a healthier overall environment by eliminating the contaminants that would otherwise be present in the water. It is also an important aspect that these initiatives help to promote the natural hydrological water cycle. Instead of being trapped on a contaminated, impermeable roof, water is able to flow freely into the ground and continue its natural process.
Water is our most valuable resource for our living, in which the majority of it goes down the drains, which is called wastewater. Wastewater is the fresh potable water that is being used. Problem is, we are wasting it immensely, without caution, that the future cannot hold up fresh water as the population increases with time if our consumption continues. Wastewater includes two subdivisions, gray water and black water. And each wastewater type must be treated in order for it to be reused for appropriate consumption. Treatment will save groundwater shortages and helps aquifers replenish itself adequately. Gray water is the wastewater that goes down the drain from showers, bathroom sinks, and laundry machines. The gray water is 60% of the household's discharged water. It includes chemicals like cleansers and soaps. Treating water for irrigation and toilet flush water, it first needs to go through a filtration tank to remove particles. It is also aerated to remove bacteria. Then, the water is filtered through sand and plants that use up nutrients that treat the water. Most of the water gets recycled back into non-potable uses in the building, while the remaining water filters back into the ground. And the last stages for filtration is for the water to pass through a chlorinated tank and an ultraviolet disinfection system. It is to eliminate any bacteria and particles remaining. Recycled gray water is ideal for gardening and toilet flushing, in place of using fresh potable water. Black water is the water that has been combined with human waste and is flushed down into sewage. Contaminated water from kitchen sink and dishwashers is considered black water due to it containing harsh substances like grease. The treatment includes different filtration tanks like aeration, where air and water is injected to multiply bacteria. The sludge settling tank is where circulates water and includes bacteria that take up oxygen. And then the water passes through a natural way of filtration to kill bacteria and pathogens before it is replenished back into the aquifers. It can be also used for landscaping. As for kitchen sinks, before it goes and joins the black water, it first goes through a filter tank where a mesh traps in any floating oil in water. Alternatively, we can use composting toilets that uses zero water. The toilet functions include the chamber. The chamber holds up the solids and the liquids, and an evaporation exhaust. Without using any drop of water, waste drops down via gravity into the chamber. The solids sit on a drying tray and the liquids sink to the bottom of the chamber. As sun rises, hot air is lifted up through the ventilation pipe and into the atmosphere. And that's when cool air drops in through the side vent for sufficient oxygen flow in the chamber. This process allows the liquid to evaporate out of the chamber and the solids shrink 5% of its size, leaving no odor behind. After chamber is filled with waste, it is taken out to be used as fertilizers. This alternative waterless toilet can be the new generation model to save our fresh water.
By combining all the aforementioned initiatives, a net zero water building can be achieved. This means that all the water required by a building is harvested and recycled throughout the year, as well as all the wastewater managed on site and in a closed loop system. A net zero water building is completely self-reliant in regards to water use, and it should be established as the go-to norm for future building designs where conscious consumption is the focus.